All right, so this lesson is on addition and subtraction with algebra tiles. All right, so algebra tiles can be used to visually represent variables and expressions. So this is usually the legend for algebra tiles, but the legend can change. We are going to be using this legend. So shaded means positive and unshaded is negative. So when you look at your algebra tiles, a small square that's shaded would be +1. A small square like this that is unshaded, therefore, would represent -1. All right, this rectangle shape is a +x, so therefore a rectangle that is unshaded would be -x. And if we have a large square, like so, a shaded large square is a +x squared, so unshaded large square would be -x squared. All right, so this is our legend for algebra tiles. All right, so we have an example here. We're going to use algebra tiles to represent the expression 2x squared minus 3x plus 4. So we're going to use the legend that we have right here. So again, positive little square for our constant. Rectangle, if it's shaded, represents x. Larger square, if it's shaded, represents x squared. And if it's unshaded, represents negative. So we have 2x squared, so that means we're going to have two large shaded squares. All right, and to shade them, I just kind of shade them like this. All right, then we have -3x, so that means we'll have 3 rectangles that are not shaded. And then lastly, we have +4, so 4 little squares. All right, so this is what it would look like using algebra tiles. So again here, the two large shade, oh sorry, these ones would have to be shaded. I forgot to shade these. Shaded is positive. Thank you. All right, so these two, that represents the 2x squared. These 3 rectangles, that represents the -3x. And then these 4 shaded small squares represent the +4. Here in this example, convert the following algebra tiles to an algebraic function. So what we can do here is if we have a positive and a negative tile of the same size, they will cancel each other out. So again, if there's a positive and a negative tile of the same size, they will cancel each other out. So here we have a positive tile and a negative tile. Those two will cancel each other out, right? Because a positive and a negative become 0. So we're left with one large shaded tile. Here we have 2 rectangular shaded tiles and we have 3 unshaded tiles. So a positive and a negative will cancel each other out. A positive and a negative will cancel each other out. All right, so same thing. Now we are left with the little squares. So a shaded and unshaded cancel each other out, and we're left with 2 shaded. So now we can come up with our expression here. We have a positive x squared tile. All right, so leaving us with 1x squared. Then we have 1 unshaded rectangular tile. So that will be -1x. And then we have 2 little shaded tiles, which will represent +2. Recording. The other way to look at this is if you wanted to, you could write out everything. You could write out, this is a 1x squared. This is the -1x squared. This is the +x squared. This is an x. This is an x. This is a -x. negative x, and then we have positive 1, negative 1, positive 1, positive 1. All right, and then you can cancel out here, like 1x squared minus x squared, cancel each other out. We have an x minus x, we have an x minus x, and then here we have plus 1 minus 1, it cancels out, and then you can still see we still end up with the same. We still end up with x squared minus x plus 2. All right, so adding and subtracting polynomials using algebra tiles. So you're going to model the polynomials with tiles, simplify the equation by canceling negative and positive tiles of the same size, and then determine the solution by counting up the remaining tiles. So let's say we had an example like this, 2x squared minus 3x plus 4, plus x squared plus 5x minus 6, and then we have to model it using algebra tiles. So here, you'd model the polynomial with tiles. So we have 2x squared minus 3x plus 4, and then we have 1x squared, positive 5x, and then minus 6, just like what was in the expression here. All right, and then you're just going to simplify. You're going to cancel any negative and positive tiles of the same size, which is shown here, and then write out the remaining tiles as the solution. So we're left with 1 to 3x squared. So 3x squared. We have positive 2x shown here, and then negative 2. These are unshaded, so it's negative 2. So our answer is 3x squared plus 2x minus 2. All right, and if you're subtracting polynomials and we're going to use algebra tiles, so step 1, you're going to model the polynomials with tiles. Next, you're going to change the tiles of the second polynomial to the opposite color. Okay, so it's additive inverse. Then again, simplify the equation by canceling out negative and positive tiles of the same size, and then the solution will be by counting up the remaining tiles. So here's an example. We have 2x squared minus 3x plus 4, and then we have minus x squared plus 5x minus 6. So you can model this out as is, or you can write out your equation showing the subtraction. So you could do the 2x squared minus 3x plus 4, and then you can show that you've done the multiplication of the negative 1 to everything inside the second bracket. So negative x squared minus 5x plus 6. Either way will work. So in this example, they modeled it with the polynomial tiles. Still showing the subtraction. And then first bracket stayed the same. Second bracket, you just have to change the tiles to the opposite color. So everything's just been changed to the opposite color. Next step, cross out or cancel out the negative and positive tiles of the same size. And then you're left with your solution. So we have positive x squared minus 8x and then positive 10. So lastly, draw the algebra tiles to represent each of the following. So if we had 2x squared plus 3x, that would look like this. 2x squared, they're shaded, and then plus 3x, we have 3 rectangular tiles like this, and they would be shaded. All right, so here we have 3x minus 2x plus 2 minus 1. Obviously, this hasn't been simplified, but just to put it into algebra tiles, we would have a positive 3x, so 3 algebra tiles that are shaded. Then we have negative 2x, so we'd have 2 that are unshaded, and then a positive 2, so positive 2, those 2 little squares, and then 1 negative square, negative 1, that's unshaded. This could then be further simplified. positive and negatives of the same tiles. Going to be crossed out. All right, so we're left with x plus 1. Last slide, we're just going to convert the algebra tiles to an algebraic expression. So we have 3 rectangular tiles that are shaded, so that would become 3x. And then we have 3 of the little squares, they're unshaded, so this would just become 3x minus 3. All right, here, this last one, we're going to cross out or cancel out any positive and negative tiles of the same size. All right, so here we have 2 positives, so that's 2x squared. And then we can cancel out negative and a positive like that. So we're left with a negative 1x. And then here we have 1 shaded, 1 unshaded. So we're left with minus 1. So 2x squared minus 1x minus 1.